This is for Year 12 methods. It comes out of Chapter 1. It's implied domains. So 1C, question number 8. I'm going to do the last 3 questions in that set. Implied domains occur when there's something about the function that x has a problem being, and that we have 3 situations where an implied domain is going to occur. We can't divide by 0. We can't take the square root of a negative number, and we can't take the log to any base of 0 or negative numbers. So, in this particular case, I've got a square root. Therefore, I can't take the square root of a negative number, which means the thing inside x minus 3x squared has to be bigger than but can equal 0. So I can factorise this. I can take an x out, 1 minus 3x. And if I was to consider graphing this parabola, I'm going to have one x-intercept at 0, another x-intercept at 1/3, and it's going to be an upside down parabola. I want to know when this parabola is bigger than or equal to 0, and it's bigger than or equal to 0 here, which means the x values that I want are the ones in here between 0 and 1/3. So the implied domain of f is from 0 to 1/3 and inclusive, because when it's 1/3 that is 0, and it can take the square root of 0 at 0. Okay, in J I've also got a square root. So I want 25 minus x squared to be bigger than or equal to 0. 25 minus x squared is a parabola, y-intercept of 25, and it looks like this. From negative 5 through to 5 will be my 2 x-intercepts. I want it equal to or greater than 0, so I want these values here, which means the x values that I want are these values in here. Therefore, the domain of h is negative 5 to 5, inclusive of negative 5 and inclusive of positive 5, because that's when this will equal 0 and I can take the square root of 0. In the third instance, I'm going to borrow from what I know about the sum of functions, and that if this was g of x and this is h of x, the domain of f will be the domain of g intersect the domain of h. So what's the domain of this one? Well, x minus 3 has to be bigger than or equal to 0, which means x is bigger than or equal to 3. And 12 minus x has to be bigger than or equal to 0, which means that if I move the x over, 12 is bigger than or equal to x, or x is less than or equal to 12. I'm looking for the intersection of these two. So on a number line, I wish to be bigger than and equal to 3, or less than equal to 12, and it's only in between that counts in the intersection. Therefore, the domain of f will be 3 to 12, inclusive of both, because when it's equal to 3, that will give me 0, and I can take the square root of that. It will be root 9 or 3. And when it's equal to 12, 12 minus 3 is okay, and 12 minus 12 is a 0, and because I'm adding. So that's going to be my 3 domains.